Welcome. Today we're diving deep into how we talk about AI progress. Because, well, the metaphor we choose really shapes how we react. Do we panic or do we plan? Think about James Watt using horsepower. Made the steam engine relatable, right? We need something just as effective, but accurate for AI.
Exactly. And the source material highlights a key conflict here. Right now, we seem stuck on the idea of the singularity, this passive, almost inevitable event we're heading towards. But the evidence, it suggests maybe a different frame is better, the intelligence wormhole,
hmm
which is more like an active passage. It's challenging, sure, but it's traversable, a journey we have to actively navigate.
Okay, let's trace that singularity idea back a bit. Von Neumann talked about accelerating change way back in the 50s.
Right, but it was Werner Vinge, the sci-fi writer in the 80s, then 93, who really formalized it. He used this physics term, didn't he, to describe this kind of
Yeah.
impenetrable transition point.
Yeah, an impenetrable intellectual transition. And then Ray Kurzweil really pushed it into the mainstream. He even set a date, 2045.
He did. And the engine behind that date, the core mechanism, is the intelligence explosion, or i.e., it's that idea of recursive self-improvement. An AI designs a better AI, which designs an even better one.
And it just spirals up faster and faster. Runaway intelligence.
That's the theory. But the term singularity itself, well, it implies a rupture, like a black hole's event horizon where our known laws just stop.
Stop working. Physics, economics, everything.
That's the implication. And that's the flaw, according to the sources.
Huh.
Because if the known rules break down, the whole claim becomes unfalsifiable. You can't test it. It makes it feel more like, well, a myth or a prophecy than a scientific hypothesis you can actually work with.
Okay. So why reject it now? I mean, we have seen exponential progress like Moore's law with chips for decades. Isn't the IE just the next step?
Well, the argument is that reality is starting to impose some pretty serious breaks. We're hitting real physical limits. Things like heat dissipation from processors and just the sheer energy needed. I mean, training one of these huge language models, it can use as much electricity as hundreds of homes for a year. That's not trivial. That's a real constraint on infinite instant growth.
Okay, physical limits. That makes sense. What else?
Time lags. Even if an AI designs a revolutionary new chip overnight.
Right, you still have to build the factory to make it.
Exactly. And building cutting-edge semiconductor fabs takes years and billions of dollars. So progress isn't instantaneous, even if the ideas come quickly. The physical world takes time.
So physics puts the brakes on. What about economics? The singularity often paints this picture of mass unemployment, right? Machines do all the work.
That's the common narrative. Less work, maybe universal basic income, lots of leisure time. But the economic data, and this is crucial, seems to show the opposite. It points towards the Jevons Paradox.
Okay, Jevons Paradox. Let's unpack that simply because it sounds important here.
It is. So the paradox is, when technology makes something more efficient, say, AI makes customer service agents 14% more productive, the cost of doing that thing goes down.
Okay, makes sense.
But instead of needing fewer agents because they're faster, what happens is that because customer service is now cheaper and better, companies expand their goals. They want more customer interaction, maybe offer new services.
So the efficiency doesn't lead to less overall activity. It actually increases demand for the activity because it's cheaper.
Precisely. Increased efficiency leads to increased consumption or application of that resource or service. So rather than mass unemployment, we see this massive reorganization of labor. People shift to new, often higher value tasks that the AI enables. The total amount of work actually tends to increase for those adopting the tech.
Well, it's a challenging transition, not an endpoint of leisure.
That completely reframes it. The wormhole, then, isn't science fiction drama. It's more like a complex economic and social adjustment period. Exactly right. And notice the shift in perspective. The singularity casts us as passive observers, just waiting for this thing to happen to us.
Right, waiting for the end state, good or bad.
But the wormhole framework, it puts human agency right back at the center. It insists we are still writing the story. We're the ones navigating this passage.
So what's the takeaway then? How should we think about this going forward?
It means we shift our focus drastically. Stop trying to predict the exact date the future arrives. That's the singularity game. Instead, focus on navigation. How do we manage this ongoing, probably decades-long transition?
So practical stuff.
Yes, building ethical AI systems now, creating robust governance frameworks, investing heavily in continuous reskilling and education for the workforce. It's about managing the journey.
The wormhole is a metaphor for transition then, not transcendence. We're still the protagonists here, navigating a complex path.
We are, and that leads to perhaps a final thought to consider. Much of the debate gets framed around existential risk, which is important, no doubt. But the wormhole view suggests something else too. Hope isn't a destination that some superintelligent AI will just deliver to us. Hope is something we have to actively construct through wisdom, foresight, and frankly, hard work during this whole prolonged transition. It's on us.